Hello everyone, I'm Vibhor Singh and today we'll be discussing the 8th problem of the CP-31 sheet under the 1300 rated parameter. So as you can see, this is the CP-31 sheet and the 1300 rated problems have been selected, and this is the 8th problem, scoring subsequences. The score of a sequence S1 to SD is defined as S1 into S2 so on till SD upon D factorial. So in particular, the score of an empty sequence is 1. For a sequence S1 to SD, let M be the maximum score among all its subsequences. Its cost is defined as the maximum length of a subsequence with the score of M. You are given a non-decreasing sequence A1 to AN of integers of length n. In other words, this condition is satisfied, that is, it is a sorted array. And for each k from 1 to n, find the cost of the sequence A1 to AK. Okay, so this is what the problem states. So let's try to understand what the problem is with this example, first one, that is 3 and then 1 to 3. Okay, so we have 3 as the length of the array or the sequence that we are given, and the sequence is 1 to 3. Note that the sequence will always be sorted or it will always be non-decreasing. That is, this condition will always hold true. This is given to us in the question. Now what do we have to do is, for each sub array starting from the start, so for every prefix array we have to print a specific thing. Okay, so that is, for this 1 length I have to print, for 2 length I have to print, for 3 length I have to print. What do I have to print? I have to print the score of that sub array or the prefix array. Okay, now what is the score of the prefix array? First, let's say this entire array is taken, let's say. So when the entire array is taken, I have to find the maximum value I can get of this equation by choosing any subsequence. Okay, so let's say I chose 3. Okay, so my length is 1. I'm choosing only one element. So my L is 1. So my value becomes 3 by 1 factorial, right? Because it is, see, if I'm choosing whatever values I'm choosing, their product upon the length factorial of the length of the number of elements I'm choosing from the sequence. Okay, so if I'm taking 1, 2, 3 as completely as one sequence, and from it I'm choosing only 3, then the value becomes 3 upon 1 factorial, which is 3, right? Similarly, another thing could be I could take 3 and 2 together, right? So my value will become 3 into 2 upon 2 factorial, which will again be 3, and my length is 2 over here. But let's say I choose all three values. If I choose all three values, 3 into 2 into 1, something like this, this will be upon 3 factorial. So the overall value will become 1, right? Numerator is also 3 factorial with L equal to 3, right? So similarly, I could choose only 1, I could choose only 2, I could choose 1 and 2 together, right? I could choose any combination of these elements. And for that, I'll calculate its length, and then I'll calculate using this formula that whatever two elements I chose, their product upon the factorial of the length. Now, among these values, what is the maximum value? The maximum value is 3, right? So I want the maximum value, and for that maximum value, whatever length, maximum length I'm getting. So first condition is maximum value. So whatever maximum value, for that I'm getting the maximum length, that is the score of this subsequence. So for this subsequence, or for this sequence rather, my score is 2. For this array as a whole, my score is 2. Similarly, I'll print. So what am I printing at the end? I'm printing first taking only one element as the array. Second, I'm taking these two elements as the array. Third, I'm taking these three together, right? So we are taking prefix arrays, and then we're just finding their scores and then getting the answer. So if I take only the first element, that is only 1 is there, then my score will be 1, right? Because there's only one element. Whether I choose it, whether I don't choose it, empty array also has score 1. So I'll have a score as 1. When I choose 1 and 2 together, okay, one possibility is, let's say I chose only 2, I chose only 1, and then I chose 2 and 1, right? These are the three possibilities I have for this 1 and 1 comma 2, right? When I choose only 2, my score becomes 2 upon 1 factorial, which is 2. This becomes 1, and then over here it will be 2 into 1, which is 2 upon 2 factorial, which will also become 1, right? So maximum score I'm getting is 2, and the maximum length for which I can get score 2 is 1, right? So for this case also, I'll print 1, or for this prefix of on length 2, my answer is still 1, length is still 1. And when I have the prefix of length 3, as we already see, my prefix, the best answer I can get is 3 value, for which the length is 2. So my score for this entire thing or entire array together would be 2. So my final answer will become 112. And as you can see, the answer is 112. So you can try experimenting with some other examples and try to understand the problem statement first, as it's a bit complex statement to understand. Okay. Now let's move on to the expected time complexity. So we know 1 second in Codeforces corresponds to approximately 10 raised to 8 operations, right? Now we are given that n is still 10 raised to 5, t is still 10 raised to 4, ai is still n, and then we are also given that sum of n does not exceed 5 into 10 raised to 5, right? Since we are given a bound on sum of n, I can ignore the factor of t and I can just form the complexity with n, and so I know n goes till 5 into 5 into 10 raised to 5. So anything of the order of n or n log n is a decent solution that will get accepted, but anything of the order of n square or order of n cube, something like this will definitely lead to TLE, right? Because this will go of the order of 10 raised to 10, this will go of the order of 10 raised to 15. In fact, even more than that, because we're 5 to 10 raised to 5, but we can just neglect it for now. This would be 10 raised to 11, like this will be 20 into 25, so 2.5 into 10 raised to 11, but either way it is going above the 10 raised to 8 limit. So anything of this format will work, but as soon as we go to n square n cube, we'll get TLE. So that's it for the expected time complexity discussion. Now let's try to see how we can solve the problem. Okay, so first and the most important thing to notice, this array is sorted. Array is sorted. The array given to us in the start is sorted. This is the information we have, right? Because it's a non-decreasing array. Now, let's have some values 1, 2, 3, 4, 5. Okay, this is the array I'm currently looking at. Now, till when should I include values in my subsequence, right? This is the question that will come, right? Because we have to maximize the score, and then for the maximum score, we want the maximum length. Or rather, I want to maximize this value, and then for whatever maximum value I can get the maximum length, that is my score, right? So I have to maximize this formula, and then whatever the maximum value is, I'll get the score, right? So let's say I chose any two elements, s1 and s2, okay, upon 2 factorial. This is my initial, or this is the score value I'm getting, right? Let's just call it score for now. It might get confusing, but let's just call it score for now. So this is s1 into s2 upon 1 into 2, right? Now let's say I want to choose add another value s3 into it. Okay, I want to say that s3 should also be included in this. So for this I will get s1 into s2 into s3 upon 1 into 2 into 3, right? See, if I want to include s3, then my new value will become this, right, of the formula, given by the formula, right? So effectively, in my initial, whatever value I was getting, in my initial value, I am multiplying an additional factor of s3 by 3, right? Similarly, if I'm adding the nth element, then I will be adding Sn upon n, right? Sn divided by n, right? Because till n minus 1 was already added, it was already there in the denominator. So I'm multiplying Sn in the numerator. I'll be multiplying n in the denominator, right? Now we want to maximize this value, right? We want to maximize the value. So it will be logical for us to multiply this factor only if it is greater than 1. Right? That is, s3 upon 3 should be greater than 1, only then it is helpful, right? If s3 is 2, then I'm multiplying 2 by 3 into my value, I'm effectively reducing the value, right? So if I'll multiply 2 by 3, I'll reduce the value, which is not what we want. We want to increase the value to the maximum. But if S3 is 4, then I'm increasing the value and then I can add it, right? And even if S3 is 3, so this should be greater than equal to, right? Because even if S3 is 3, I'll be adding 3 by 3, right? I'll be multiplying 3 by 3, sorry. I'll be multiplying 3 by 3 into my value. Now 3 by 3 in itself is 1, right? And multiplying by 1 will not affect my value in itself. So the value will remain unchanged, but the length will increase, right? The length will increase. And we know the score is maximum value, and for the maximum value, the maximum length, right? The score is the maximum length we can get by which we can get the maximum value. So that is why whatever value we want to add or whatever value we want to put, it should be greater than equal to 1. That is S3 by 3 should be greater than equal to 1. Sn by n should be greater than equal to 1, or Sn should be greater than equal to n, so, right? Or S3 should be greater than equal to 3, right? I can just put it at S3 should be greater than equal to 3, right? This is the condition. So now with this condition in mind, we can move on with the solution. That, let's say I have some array of the form 1, 2, 3, 4, 5, and then some values after this. So it's a very big array, out of which I'm looking at this prefix of first 5 elements. Okay, so currently I'm only focused on the calculating my answer for the prefix of these first 5 values. Okay, how can I do that? See, we have established a condition for on how we can decide whether to include a value or not, and we know that including the highest value would be, we should always choose the highest value to be included first. That is, when we are looking at this subarray entirely, first we should select this value, that is 5. First we should select the highest value, then we should select 4, which is the second highest value, because we want to maximize the product, right? So it's logical to always select the highest value first, right? So let's say I'm checking for length. Okay, that is possible length of our answer, right? Our answer is the length, right? That is the length of the subsequence, right? So let's say I'm checking for the length of the subsequence. First, I will choose the rightmost element in our subarray. And I know the rightmost element will be the largest element, since we are given that the entire array itself is sorted, right? That is, it is non-decreasing. So first thing I'll do is checking for len equal to 1. I would see 5 by 1. Is it greater than 1? Yes, it is. So I know that, yes, I can select 5 into my subsequence. My length can be 1, right? Now checking for length 2. After selecting 5, next value I'll be selecting would be 4, which will be the second largest value in our subarray, right? Which would be 4 by 2, right? Which is basically current length we want to check. So the element I'm adding for the current length divided by the current length I want to check for, again greater than 1. Similarly, when I come to 3 by 3, this is greater than, so we have greater than equal to 1 rather over here. So this is greater than equal to 1. Then when I come to length 4, when I'll come to length 4, I'll get the value 2 over here. So this is length 3 over here. This is length 4. For length I'll get 4. For length 4 I'll get 2 by 4, which is less than 1. So I say that, okay, I cannot choose this value. So our answer would be 3. That is the largest value that we can choose. Okay. So from here, am I getting some pattern? See, right now I have gotten this much of the solution. But even now, if I try to iterate like this, that is, if I try for each prefix subarray, if I start iterating from its rightmost value of this prefix subarray, so let's say I variable stores my length of the current prefix array. Okay, so I is current prefix subarray. So starting from I'll first check for I, can I include it? Then I'll check for I minus 1, can I include it? Then for I minus 2, can I include it? So on and so forth. For each I, if I'll be doing this, then I'll just get a TLE, right? Overall complexity will become n square, which will give us TLE. So I cannot just directly be doing this. Although this gives us a rough idea of what the solution is, I cannot directly do this, but I can see a pattern over here. That is, for small values of length, this condition that I have holds true. That is, the current value I'm checking at divided by the length, if that is greater than 1, it would be true for small values of length till my answer, and after which it will become false, our condition. That is, our condition is true, 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 so on till some value, and then after that it becomes false and false and false, right? And this last true value, or the highest, see, the last value, the longest length for which our condition is still true, that is our answer, right? This is our answer. That is the longest length for which our condition is true. So I can see a very monotonic function which is true for some values to start with, and then it is false for the ending values, right? So I can use binary search. I can use binary search to solve the problem, in which I'm looking for the last true value for a length function, right? Now, still, I got the binary search, but how will I implement it? Like the implementation details. So let's just understand it with the code, right? Till now, I hope this much part is clear that we'll be implementing a binary search to be able to find the last true value for our condition. Now, moving on to the code of the solution. So first we are taking number of test cases as input, and then I've taken n and the array as input, right? And I've created res, which is a vector that will store the answer, right? So for each prefix subarray, I have to store the answer. So it will be a vector. For each prefix array, subarray, I'll be storing the answer. And then this is the binary search part, which is the core of our solution. And then in the end, I'm printing the values, right? Now, how is the binary search functioning? Let's understand that. See, there are three main things for binary search: the smallest value, the largest value, that is, smallest and largest value form the search space that you will be doing, and your check condition, right? These are the three things that you have to look for. So the smallest value that we can have would be 1, right? And why is that so? See, we are given that a of I would be minimum 1, right? A of I would minimum be 1. So if I have some array with, let's say I have a subarray with only length 1, so prefix array length 1 of one value which is equal to 1, right? So even when I have only one value, which is minimum value for which it would be 1, it is better for me to choose 1, because 1 by 1 will be 1, right? Choosing 1 will still give me product or my overall equation value as 1. So my length would become 1. That is, my length answer would become 1, right? So I hope this is clear that why 1 can be taken. We don't need to take 0. We will always get 1 as our minimum answer. And then our maximum answer can be I plus 1. So why I plus 1? See, I'm starting I from index 0, and I defines the current length of prefix subarray I'm looking at. Okay. So like, let's say I is 4. So I'll have 1, 2, 3, 4, 5. Right. So like, if you see the indexes 0, 1, 2, 3, and 4. These are the indices, right? So I have overall 5 values. So the maximum length of our answer, or maximum answer, can be 5. That is, all 5 values can be selected. Let's say all 5 values are very large. All 5 values are 10 raised to 5, let's say. I can choose all of them, and my answer will just become 5, right? In that case. That is why our maximum search space goes till maximum search space goes till I plus 1 for each of the sub prefix array of length I. And then we have our condition, and we are calculating the mid, and then this is the if condition. So how is the if condition working? So see, let's say we have the first 5 values 1, 2, 3, 4, and 5. Okay, so I have my I is equal to 4 currently, right? Now mid is the length that we want to currently check for, right? Mid is the length we want to currently check for. Now how do we check for length? See, we have to check what value we'll be currently including, right? So if length is 1, I'll be currently taking this value. I'll do 5 by 1, right? Now if length is 2, I'll be looking at this value. I'll do 4 by 2. That is the value I'll be currently including because of this length divided by the length, right? Or I'll be comparing 4 with 2, right? That is, if 4 is greater than equal to 2, I will be selecting my condition is true. This is what I have to check, right? 4 should be greater than equal to 2. 5 should be greater than equal to 1. 3 should be greater than equal to 3. So when I have the length variable, how can I reverse compute this? See, let's say my length is currently 3. If my length is 3, I want to look at this variable, right? this is at index 2, my I is 4. So the relation between my mid and I and the current value I have to check is, I will be looking at array of I minus mid plus 1. See, when I is 4 and mid is 3, I want to check value at index 2. So I minus mid plus 1 is the index I'll be checking at. And if this value is greater than equal to mid, if this value is greater than equal to mid, then our condition is true. So as long as our condition is true, we can move the search space forward, right? See, our search space, if our condition is true, let's say we are somewhere over here, I want to move the search space forward, right? And uh, if we do vice versa, that is, if my condition is false, I will be moving the search space backwards. So over here I have this thing, if this condition holds true, that is a of I minus mid plus 1 is greater than equal to mid, I will move my L forward, that is L is equal to mid plus 1. Else I will do R is equal to mid minus 1, since I have to move the search space backwards in the else part. So that is what we have here. If A of I minus mid plus 1 is greater than equal to mid, then I'm increasing my search space L forward, else I'm moving my search space backward with R, and in the end I'm pushing back R in my solution, in my answer. So that's it for the solution discussion. Moving on to this time complexity discussion. So overall time complexity for taking input would be order of n. Then this overall for loop will run in order of n, in which we are also doing the binary search within it, right? So for overall complexity will just become order of n log n, right? Our binary search will it will run in log n, and the outer loop is running in order of n. So overall complexity of this part will become order of n log n. And then finally for printing the solution, again our complexity will become order of n. So overall time complexity will be order of n log n for each of the test case, or like since we have the constraint for sum of n, we can just write an order of n log n. And the overall space complexity, I've taken the vector of length n as input, and apart from that there's a res that is the answer vector, which is again of length n, but apart from that there is no other extra space. So overall space complexity will also be order of n itself. So I hope the solution is clear. Thank you.